Hi there, that's my newest piece of junk to play with. It's a HP EVA6000 RAID controller. In fact, the lower part here is disks and RAID controller, and the stuff above here is another EVA controller, but someone has taken all the important parts from it, so it's only a piece of garbage here. And that's the rest of the rack, which is quite empty. And that's how it looks from the back side. A lot of empty space, the disassembled unit and the complete unit with 4 shelves full of disks and some power distribution. Okay then, time to turn it on. The display says it's a 6100 EVA, or EVA, how we call it, but I think it's more like a 6000, because I think the 6100 has a different kind of controller. But if you really like to know how it is, you can check the manuals. There is a EVA6000, 6000 and 8000, and the main difference is the number of disk drives or the number of disk shelves that are included. This series of EVA controllers has a very special feature. They can play music, and I'll show you how that works. It's relatively simple. You have the disk enclosures here. You can see the disk enclosure ID, which is visible here. You can see the lowest controller has ID 1, then the next has ID 2, 3 and 4. And if these disk shelves have a problem, for example power loss, for example loss of a fiber channel connection, they beep, and the beeping sound, the pitch of the beep corresponds to the unit number. So the lowest unit number here has the lowest sound of alarm. Let's try that. I pull one of the plugs. That's unit number 1 error. And unit 2 sounds like that. Number 3. Well, it seems they changed the firmware a little bit, so I remember I had systems with more than only 2 different tones. I think this one has only 2 tones, a higher and a lower, and that repeats for box 3 and 4. So yes, it's a pity. I wanted to show you that, but well, that's something that changes from time to time without any notice. By the way, the EVA systems have a rather unique kind of determining the IDs of controller boxes and disk boxes. They use this cable here that goes down, 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 and it has a connection for every device and a terminator at the end. And that works like this. There's a set of cables like this with some kind of RJ45 connector, but this one has 10 pins, while the RJ45 normally only has 8. And they also have an extra plastic tab here that makes it impossible to find a normal plug or to put any other plug into these sockets. And then what they do, they simply connect it together. Then you get a terminator at the end, at each end, so also on this end. Here, this is a female terminator. On the other side you need a male terminator, and then you take that gray cable, plug it in here, and the other side goes to the box, to any box, to the controller box and to the disk boxes. And from the position here in this chain, the box knows which address it has. So it's maybe simple from a firmware view, but of course that's rather expensive, all these connectors and cables and special wiring. Well, I don't know why they did that, but for some reason they thought that's easier than doing it in the firmware. And here is how that magic rope trick works with this ID cable. So we start with a connector on the top, and I'm only drawing 5 wires. The connector has 10, but the principle is the same. 1, 2, 3, 4, 5. And then comes the first connector to the side, here. And then the next connector here. And between the connectors, the first wire gets the last wire. 2, 3, 4, 5. So, always between 2 connectors, the wire changes from the first place to the last place. Then the next connector, of course. Also the first wire becomes the last. 2, 3, 4, 5. And in reality there are 10 wires, but that's the same. And then 5, another connector here, and you daisy chain all that. So that of course means you cannot have more than 10 different IDs, because after 10 you get back to the first configuration and all the wires are in the initial order. But with that, so then the 10 wires go to any device, for example a disk box, another disk box, and a controller. and they all see different IDs. So I don't know what kind of signals they have here. Probably just a DC level, 5 volt TTL, I don't know. Well then, let's take it apart, shall we? Of course we do. First, remove the front panels. Then, loosening 2 screws. And the controller slides out. Of course, we have to disconnect all the cables. And that's it. And here we have the rate controller, the EVA controller, or the HSV200. And that's not a server, that's not a PC, it's just a rate controller. And that's how it looks inside. Let's start on the front. We have 2 battery modules. They are heavy. It's a lead acid battery. It's, I think, well, I have an open one here. It's 6 2-volt cells, lead acid, 4.5 amp hours each, and a little bit of voltage regulation, charge controller. I can also take it out here. Yeah. And that's one of the modules I tried to repair, because simply changing the cells doesn't help. There is a chip, and that chip stores any problems, errors, and so, and if you just replace the cells, the stored errors will still remain, and the module still thinks it's not good, so I must find a way to erase that. I already found one, but it doesn't really work yet, so that's a little bit work to do. There are 2 battery modules, because if you change one, you never have the situation that no battery module is inside, because one of the unique features here, or maybe, well, it's done on purpose, if you have no working battery modules, all the disk will be set offline, so you cannot write to the disk, so you don't even see the disk on your remote systems. And the reason is that's the battery for the cache memory. So it has a write cache, so it first writes everything to that cache memory, and if there is a power outage, they rely on this battery to keep the data before it is written to the disk. And if there is no battery available, because all batteries are faulty, they simply switch off the disk. So they don't switch it off, but they set it offline, and yeah, you will notice that, because all your disks are done or gone then. So then we have a fan module. There is a radial fan here inside, and there is a second one here. Everything is there twice, and you can also open that door. There is space for 2 more batteries. So if you want to increase your battery backup time, if you live in a country with long power outages, that's probably the way to go. On the back side we have two power supplies, 1 and 2, and they're a bit dusty. Technical data, they are 400 watt each, so it's not a huge power supply, but in fact that's only a rate controller and not a server, but it's a powerful rate controller, and of course it needs two independent power supplies. What do we have on the back side? We have an intercontroller connector. That's only a short cable that goes from one controller to the other. So while the controller itself is almost fully redundant, we have a second one with also two power supplies, 2 batteries or 4 batteries and all that stuff. So if one controller box fails, the other one takes over and works as nothing happened. And the intercontroller bus here, it's to exchange data from the cache, so one controller has always a copy of everything of the other controller and so on. We have 2 serial ports, you normally don't use that. We have a cab connector, that means cabinet, that's the cabinet address, the cable I explained before. Then we have fiber port 1 and 2. These two go to the servers. And we have a management port and the disk port and another management port and another disk port. They go to the switches that are integrated in the rack between the disks and this controller. And here we have a small flash card with firmware, so in case you have to replace a controller, you can take the firmware from the customer, put it into your controller, and everything runs as before. There is also some kind of network connector, but I have no idea what this is for. Maybe for factory testing and stuff. UID button, for all those who know HP servers know what that means. You press the button, it lights up blue, and it also lights up on the front. That's convenient when you have a long row of racks. You press the button when you're behind the rack, and when you walk around you see which machine it actually is. Here we have standby and on, a simple switch, but there is also a shutdown procedure that turns the machine off by software, even if it's in the on position. Doesn't matter. So let's switch it off. What else is inside? Here we have the 2 RAMs that are used for the system and for cache, for data cache. They have a size of don't know. Yeah, I would say it's about 2 GB each. Together they are 4 GB, and these caches are then mirrored to the other controller, so that each controller always have a full set of data, just in case that one controller dies, the other one knows what to do. What else do we have? We have some processors underneath relatively small heat sinks. So they are mainly used to calculate all the rate data, the parity and all that stuff. We have a connector that goes to the back plane where the fans and the batteries are. We have large power connectors that come from the power distributor or connector board here. Then we have individual power converter. So I think the main output here on the power supply is, let me take my glasses, 12 volt, 32 amps, and a little bit of 5 volt, but that's not the main thing. So all the other voltages like 3.3 volt and 5 volt and whatever you need, maybe negative voltages, they are converted here. We already have seen the RAM. There is some Xilinx stuff going here. PMC, that's probably the fiber channel interface chips, because there are 2 of them and they go directly to that side where the fiber channel connectors are. Then we have a fancy looking Dallas chip, power cap with crystal, so that's the real-time clock. And in fact that's a complete clock. It has a battery. Yeah, does it have a battery? Does it have a battery? Yeah, I think so, because that's why it is so thick. So it has a battery, it has a crystal, it has a chip. That thing gives you the time. So if you desolder that, it will still run, still output time, and well, nobody sees it when it's lying on your desks. Yeah, I think that's about it. The rest of it is just cables, disk boxes. That's not so very interesting. Okay, I hope you enjoyed that little excursus to 2005 high-end RAID systems. Thanks for watching.